Good morning, my dear students. Today we are going to planes in space, three-dimensional geometry. So how to find the equation of a plane in 3D? So we have the plane equations. Concepts are first one. Equation of a plane in normal form. This is the first one. We have the different type of equations. The first equation is equation of a plane in normal form. Second one, equation of a plane passing through point and perpendicular to vector. This is the second concept of plane. Third one, remember third one is equation of a plane passing through three non-collinear points. Passing through three non-collinear points. This is the third one. Fourth one is intercept form. Fifth one, equation of a plane passing through intersection of two planes. These are the 5 different forms in planes. All 5 different forms are very, very important. Mainly for examination point of view, first theorem and second theorem only important. Remaining are formulas enough. But I will give at least 3 theorems. Remaining take as a directly formulas. And next one, condition for coplanarity of two lines. It is very, very important. Coplanarity. This theorem also very important. Condition for coplanarity of two lines. Okay. Next one, seventh condition, seventh one, angle between two planes. It is also very important. All these are formulas only. Angle between two planes. Next concept here, angle between plane and line. So related to last topic. Next, ninth topic, that is distance of a point from the plane. Distance from the plane to the point. So distance of a point from the plane, that is either horizon or any point in the plane. This is the whole concept of planes. Very, very important chapter for CET point of view also. Remember, okay, today we are going to equation of a plane in the normal form. They are asking as a theorem like this. So it is very, very important theorem. So how to ask theorem here? Derive the equation of a plane. Derive the equation of a plane in normal form. Derive the equation of a plane in normal form in both vector and Cartesian form. Both vector and Cartesian form. So this is the very, very important. Means here normal vector given, okay, perpendicular vector and distance from plane to the horizon also given. That meaning normal form meaning perpendicular to plane. Normal, okay na? Perpendicular to vector, perpendicular to the plane and distance of a plane, perpendicular distance of a plane from the horizon. Remember all of you this meaning. How to derive the equation of a plane in the normal form? So we have to take Cartesian system in space. So let us take 3D geometry, three-dimensional geometry. X-axis, y-axis, z-axis. This is called horizon. Plane nothing but what? Surface. We know all of you. So that's why just I take the surface like this. This is the surface of a plane. Okay, this is called plane. Plane is generally denoted by which letter? Pi letter. Okay, remember all of you. Surface nothing but plane. So it is denoted by pi letter. Okay. So these are the points A, B, C. According to statement what he has given. So that should be present on the diagram. How to present here? Normal form meaning here normal vector. So to the plane. So let us take normal. So I consider this vector. Okay, this is perpendicular to the plane. So ON. Let ON be the normal vector to the plane only. So what do you call this one? ON is what? Normal vector. Okay, how to write the derivation here? So first sentence we can write, let ON be the normal vector to the plane. Okay, we write the first sentence. Let ON be the normal vector to the plane. Over. Next he also given what? Distance from the distance of a plane from horizon given. So this distance is given. So what is the perpendicular distance given? D given. So dB the. So one more thing, it is called a vector. Okay na? Director. It has a direction. Direction means it is unit vector. It has unit vector. So let us take, let n cap be the normal unit vector. Normal unit vector of which one? ON bar. So ON vector that is. Then it is a vector means here ON is a vector. It has a magnitude and direction. Magnitude and direction means we can write ON cap, that is n cap. N cap is equal to ON bar divided by magnitude of ON bar. Okay, this is the unit vector definition. N cap is equal to ON bar divided by magnitude of ON bar. This is equal to ON bar divided by D. Now vector ON is equal to magnitude into direction, that is D into n cap. D into n cap. So magnitude into direction. So we got it ON vector. So ON vector is equal to distance into magnitude, unit vector this is. Okay, are you following this one? Next we are going to any point we consider here. D is not written. So firstly we can write what here? DB is what? Right, compulsory. D is what? The perpendicular distance of a plane from the horizon, where D be the, or let, before also we can write here solution of this one. Let, okay, no problem. Let the perpendicular distance of a plane, the perpendicular distance of a plane from horizon, right? Horizon is D. Here both vector and Cartesian form. So firstly we take the perpendicular distance of a plane from the horizon is D. Let ON be the normal vector and n cap be the normal unit vector of ON vector. Then n cap is equal to ON divided by D. or On vector is equal to D into n cap. Next here we take the any point in the plane. This is called general vector x, y, z. Let P is equal to x, y, z is any point on the plane. Now join OP. If I join OP means we get OP vector. Let OP vector is equal to R bar. So that is I am writing here. Let R bar be the, this is only description part. R bar be the position vector of the point P x, y, z with respect to horizon. Then OP vector is equal to, what is the OP vector? R bar. So these are the things taking on the plane. So what is the first one? Perpendicular distance of a plane from the horizon is given already in the statement, normal form, that is D. Let On bar be the normal vector to the plane. It has the direction cosines. Let n cap be the normal unit vector of On vector. Then On vector is equal to distance into magnitude, D into n cap. Therefore, P is any point on the plane. That means let R bar be the position vector of a point P with respect to horizon. Any point, the general point. So OP vector is equal to R bar. Now join Pn vector. So this is the Pn vector. Now this direction. Observing all of you here, this is a triangle OPN. From triangle OPN, using triangle of addition, triangle of two vectors, triangle of addition of two vectors, what do you write here? OP vector plus Pn vector is equal to On vector. This is triangle of vector addition. Triangle of vector addition. Using triangle of vector addition, OP vector plus Pn vector is equal to On vector. So do you know that OP vector? What is the OP vector? R bar. R bar plus Pn vector. We don't know means take as it is. Pn vector is equal to On vector. We have that is D into n cap. From this, Pn vector is equal to Dn vector, D into n cap minus R bar. So we got this one. Now you observe what here? You observe what? Pn vector and On vector what? These are perpendicular. Why? Because the reason is actually On vector is perpendicular to what? Plane. But Pn vector lies along the plane. Pn lies along the plane means On is also perpendicular to Pn. So On is perpendicular to Pn. So since Pn vector perpendicular to On vector. So perpendicular, if two vectors are perpendicular, what is the condition? A vector and B vector are perpendicular, then condition will be what? Dot product will be 0. So Pn vector dot On vector is equal to 0. Substitute here. Pn vector is, that is equal to Pn vector D into n cap minus R bar dot On vector D into n cap is equal to 0. Multiplying these two terms, multiplying here dot product D into D, D scalar, this is D square n cap dot n cap minus R bar dot D into n cap is equal to 0. What is the I dot I cap dot I cap is equal to 1. J dot cap J dot is equal to 1. N cap dot N cap is equal to 1. So D square minus R bar dot d into n cap is equal to 0. Can you take d common? So throw out, cancel that. D minus r bar dot n cap is equal to 0. Taking on right side, r bar dot n cap is equal to d. This is called, what do you call this one? Which is called equation of a plane in vector form. In which form? Vector form. This is called equation of a plane in vector form. This is very, very important. Okay. After the deriving equation of a plane in vector form, so this is vector form completed. From this we can easily derive the Cartesian form. That is simple, Cartesian. Whenever you know the vector form, Cartesian form is very easy. So Cartesian form very easy to find out. R bar is what actually? Position vector of the point P. So let R bar is equal to what here? X into I plus Y into J plus Z into K. N cap is what? Normal unit vector. It has direction cosine. So n cap is equal to L into I cap plus M into J cap plus N into K cap. D is what? It is a scalar distance. Substitute in equation 1. X into I cap plus Y into J cap plus Z into K cap dot L into I cap plus M into J cap plus N into K cap is equal to D. Applying dot product, this becomes Lx plus My plus Nz is equal to D, which is called equation of a plane in Cartesian form. Okay, this is the Cartesian form. Remember all of you, very easy to solve the question. Derive the equation of a plane in the normal form. Normal form meaning perpendicular to the, perpendicular vector to the plane, perpendicular vector, and also perpendicular distance of a plane from horizon is given. That is the meaning. All of remember. So take the plane here in the Cartesian system. Let ON bar be the normal vector. So this is perpendicular to the plane. And perpendicular distance of a plane from horizon is D given, as given already in the statement. Next it is a vector, means it has a direction. Let n cap be the normal unit vector. This is, remember, a very important word. If n cap be the normal unit vector, then ON vector is equal to D into n cap. Okay, from this only unit vector definition this is. Now you take the any point on the plane P, X, Y, Z with position vector R bar. So OP vector is equal to R bar. Now using triangle of vector addition, OP vector plus Pn vector equal to On vector. Substitute Pn vector is equal to D into n cap minus R vector. Okay. Now observing here, this Pn vector lies along the plane only, along the plane. It means, so On vector is perpendicular to plane. It means it is also perpendicular to Pn also, Pn vector. If two vectors are perpendicular, the dot product is always 0. So Pn vector dot On vector is equal to 0. Substitute, simplifying. Here you remember that n cap dot n cap is equal to 1. So we get R bar dot n cap equal to D, which is called equation of a plane in the vector form. What is the equation of a plane? Normal form of here, normal form. R bar dot n cap is equal to D. Next, Cartesian form. R vector, n cap vector, right? Substitute in the equation 1, we get Lx plus My plus Nz is equal to D. This is called equation of a plane in the Cartesian form of a normal form. L, M, N, these are called direction cosines. D is what? Where D is the, remember all of you here, perpendicular distance of a plane from the horizon. All of you remember this concept here. I will show little change here. This model, r bar dot n cap is equal to D. This is called equation of a plane in the normal form. Vector form, that is, vector equation of a plane in the normal form. Next one, Lx plus My plus Nz is equal to D. This is Cartesian equation of a plane in the normal form. I can write here r bar dot n bar is equal to D and Ax plus By plus Cz is equal to D. So both are differ here, observing all of you. This is normal unity vector. This is only normal vector only. N bar is the normal vector. It is not a normal unity vector. Here D is what? Perpendicular distance of a plane from the horizon. Do you remember here? Perpendicular distance from horizon to the plane. But here D is what? A simple constant only. Remember. Okay. If I divide with magnitude value, both sides. If I divide with magnitude, this becomes what? N cap. So n bar by magnitude of n bar is equal to n cap. So both are different. If there is given in the form, whenever you see r bar dot n bar is equal to D, convert into normal form always. Okay. Here D is a simple scalar, but here perpendicular distance of a plane from the horizon, don't forget this one. Observing L, M, N, these are called direction cosines. D is the perpendicular distance of a plane from the horizon. Here A, B, C, these are called direction ratios, but D simple constant only. If you divide with magnitude value, then it is converted to normal form of a plane equation. Are you observing difference? So this is the first theorem of a plane equation. All of you practice this theorem with notes also take here. So this is the concept. Tomorrow I have to see the equation of a plane passing through point and perpendicular vector. Okay. Thank you.